Welcome dear students. In the previous videos of proving a number as irrational, we have learned about a method of squaring in which whenever a number is present in a single form without any mathematical operators such as plus, minus, divide and multiply were proved to be irrational by the method of squaring, right? In today's video, we are going to learn if sum, product, difference or division of two or more numbers is present, how you are going to prove that as irrational. Again, the method will be of the same time. We will use the method of contradiction. Again, we will assume that the given number is rational provided a and b are co-prime. Co-prime are the numbers who has their HCF as 1, and then we'll prove that our contradiction or our supposition was wrong and hence these should be irrational. So let's say if there was a single number, we could have used a squaring, but in this method we won't use squaring. There will be some different method. So these are the examples. When there is a sum, there is a difference, there is a division and there is a number which is being multiplied by an irrational number. Let's see how we are going to prove them. Usually most of the students makes mistake. They think that every proof of irrational number includes squaring, and even if there is a sum, product, difference, they end up doing the squaring in the final examinations, and that is an error method, right? Now we'll see if sum is present. So let's say 3 plus root 2, again we will take it as a by b. Again a and b are co-prime. A and b are co-prime. It means their HCF should be 1. They should not have any common factor other than 1. So again we will say if possible to the contrary, let us assume that 3 plus root 2 is rational provided a and b are co-prime numbers. Right. This is a kind of a template. So whenever you will have a question of a rational number, you will use the same wordings. Either it is for this real number or square single number, or it is for the sum, product or difference. So now let's see what happens over there. 3 plus root 2 is a by b. Root 2 will be a by b minus 3. You can leave it over here, or you can take a step further and take the LCM and write it as root 2 as a minus 3b by b. Now wherever you put it up to, then again the question terminates over here. There is no mathematical portion that is left to be done. After here again the English will prevail. You will say that a, b and 3 are rational numbers, or you can also write are integers. Now you know what integers are. Integers are positive or negative whole numbers. You don't have fraction in them. So integers, positive, negative, whole numbers. Hence basics are very important. If you know about these things, so it will be very easy for you to understand. A, b and 3 are integers, hence. Now this is in p by q form. So you will write hence a minus 3b by b will be rational. Or the students who have taken this first step, again the equation remains the same. A, b, 3 are integers, hence a by b minus 3 will be rational, because you still have one p by q term over here, right? Now since it is rational, so this 3 plus root 2 should be rational, because we have assumed that 3 plus root 2 is a by b, right? So then this should be rational, but this contradicts the term, this contradicts the fact that root 2 is irrational. Root 2 is irrational, hence our supposition that 3 plus root 2 is rational is wrong. Hence 3 plus root 2 is irrational. So this is also one of the other methods of proving a number as irrational when there is a mathematical operator, that is plus, minus, multiply or divide, is given to you. And I'll come into it again that mostly the mathematical part is only up to these 2 or 3 steps only. Before this and after that is only the words, the template that you have to rewrite in the examination hall. Well, if I talk about the final examinations, then the squaring methods is a must question for the examinations, whereas this can be important for your school test or unit test or just a class test. Right? We'll see 1 or 2 more examples. Let's say 3 minus root 5 is a by b. Let's say 4 root 3 is a by b. And let's say 7 divided by root 3 is a by b. So in this case, we prefer to take the irrational value in positive. So I will shift it to the other side. A minus 3 by b is root 5. Then 3b minus a by b is root 5. Again, you can use the template over there. Right? In this case, we will write 4 root 3 is a by b, root 3 is a by 4b. With this again the template. And over here we will first of all cross multiply. 7b is a root 3 b, 7b by a is root 3, and that's it. Right. So this is the method where you will be proving these numbers as irrational without squaring them. Just solve them up to this part, and after that you can write that all of these a, b, 3, 7 or whatever the numbers are integers, hence these will be rational, and then you can follow up with that thing. Right? Hope you have understood it. Thank you.